The second problem also has to do with matter, but not the kind of matter that consists of atoms, something else. What I'm showing you here is an image of the Andromeda galaxy. It's our nearest neighbor to the Milky Way. We can look at an object like that, and we can look at how many stars it contains, how much gas it contains. Basically, we can get a pretty good inventory of all of its visible matter. When we do that, we can work out, just using the laws of gravity, how stars should move around a galaxy like this. And you get something like this. This is a predicted rotation curve of a galaxy like Andromeda. As you move away from the middle of the galaxy, we find that stars should be moving in slower and slower orbits because they're farther and farther away from the concentration of mass. This is the same reason, basically, that Pluto moves in a really slow orbit and we move in a much faster one. It's the same basic idea. In the 70s, though, astronomers began to measure rotation curves that look more like this upper line. These galaxies seem to harbor a lot more mass than we could account for in terms of stars, gas, dust, and planets. Furthermore, the mass we couldn't observe seemed to be puffier, extending out to much greater distances from the middle of the galaxies. We had a lot of arguments and debates, but ultimately a consensus formed that what was going on here is that most of the mass in galaxies isn't made of luminous material. It's not made of things that appreciably radiate, absorb, or reflect light. Instead, it's made of something else, something that, for a lack of a better name, we just call dark matter. We don't know what dark matter is. Just because we can give it a name doesn't mean we understand it. No one can blame the experimentalists. Us theorists told them this is what you need to find, this is the kind of experiment you'd have to pull off in order to do it. They said, okay, we're up for that challenge. They went out and they did it well, but the things we told them to look for weren't there. Best we can tell, WIMPs are either harder to look for than we thought, and that's possible. I can write down some theories of WIMPs that can evade these constraints. I have to work a little bit, so it's a little harder than it used to be, but it can be done. Or maybe it's telling us that the dark matter wasn't produced in the early universe in the way we had long imagined. Maybe things played out differently in the universe. Maybe space expanded at a different rate. Maybe there were other forms of matter and energy present. Maybe dark matter's origin wasn't in this thermal bath like we imagined, but maybe it was produced in some other way. Any of those could